All right, so this is section 9.6, our last chapter from, or our last section from chapter 9, and we're going to talk about the equations of circles. And we'll do most of it today, and then on Monday we'll just add a little bit to this. On Tuesday we will review, and then on block day we'll have our test on chapter 9. So we've talked about the definition of circles a couple of times over the course of the year. So I just want to remind you what the definition of a circle is. Yes? Yeah. So let's remember how we defined a circle, and that will, hopefully it'll help us see a little bit why the equation looks like it does. So we define a circle as all points that are the same distance from a center. And we said that distance, the distance was the radius. So we have a center, our center and our radius are kind of our two main things for circles. And we just with our math boxes, we did one problem with the distance formula. The way that we come up with the equation of a circle is it actually comes from the distance formula. So we would use the distance formula to write our equation. So we're going to start with an easy one. The equations of circles are really nice. They work really easily. They look a little bit complicated, but they're not too bad. If we have our equation for a circle with the center at 0, 0, so if we have our center at the origin, the equation is x squared plus y squared equals r squared. And r is the radius. So anytime you see an equation that looks like this, x squared plus y squared equals some number, that's the equation of a circle. And this comes from the distance formula. If we solve this equation for r, to get rid of this square root, we could write that r equals the square root of x squared plus y squared. And this square root of x squared plus y squared looks just like our distance formula. This is the distance of our point from 0, 0. So this equation comes from we expand, this equation is our distance formula. We just square both sides to get the equation of a circle. So the equation of a circle comes from the distance formula. So an example of the kind of problem that you might see with the equation of a circle, with the center at 0, 0, these are really nice. We want to know the radius. We have a circle, x squared plus y squared equals 49. And we want to know the radius. So our equation is x squared plus y squared equals r squared. So from our equation, r squared equals 49. So r is the square root of 49, or 7. So when we have the equation of a circle, to find the radius, all we have to do is take the square root of this number, and that gives us our radius. So that's, and when our center is at 0, 0, that makes it nice and easy. Questions on that equation? So when our center is at 0, 0, this is our equation. Now, what happens if we move the center? Yeah, go ahead.
So x squared and y squared, do they just give you this, or what is x squared and y squared?
X squared and y squared. So the circle is, this circle would be all the points where when we add the square of x and add the square of y, they add up to 49. So if we graph this circle and we looked at the circle, let me,
Oh, so it's on the graph.
so that would be on our graph. So if we graph this circle, we would have something like this, and I'll just draw a really rough graph. My circle would look like this, more or less. This is 0, 0, and the radius is 7. So if we look at any point that's on that circle, and we find the x and the y value of that point, and we square the x and we square the y, they would add together to get 49. Any point on that circle, the x squared plus the y squared would equal 49. So that's the way circles work. Does that answer your question?
Yeah.
Okay. So when our center is at 0, 0, this is our equation. We just have x squared plus y squared equals r squared. But what if we move the center? So let's come up with our equation. If we move the center of the circle. The equation looks almost the same, but we have a couple of extra pieces in there to tell us where the center is. The equation tells us where the center is, and the equation tells us what the radius is. So it works out really nicely. So if we have our center, and when we're talking about circles, we use h and k for the coordinates of the center. So this is just the x coordinate and the y coordinate. So that's just a point on the graph. And the radius equals r. Our equation is x minus h squared plus y minus k squared, and that equals r squared. So when we have the equation of a circle, it tells us where the center is, and it tells us what the radius is. Now, one thing to notice here is that the sign here on h is positive. The sign here on h is negative. The sign here on k is positive. The sign here on k is negative. So whatever number is here, when we put it into our equation, the signs switch. So we switch the signs between our point and our equation. So let's look at a couple of examples of this. Questions on the equation before we move along. And before we move on, let me point out, if we solve this equation for r, I just want to show the connection to the distance formula. If I solve this equation for r, I would take the square root of both sides to undo the square. So I would get r equals x minus h squared plus y minus k squared. And this is exactly the distance formula. This is x1, x2 and x1, y2 and y1. So this equation is exactly the distance formula. So our equation for a circle comes straight from the distance formula. All right, so let's look at a couple of examples when our center of our circle is moved. These, working with the equation of circles is really easy. Let's say we have our equation x minus 3 squared plus y minus 1 squared equals 20. And we want to find the center and the radius. So let's do the easy one first. In our equation, we have x minus something squared plus y minus something squared equals r squared. Whatever this number is that's by itself over here, all we have to do to find the radius is take the square root of that. So r squared, we know from our equation, r squared is 20. That tells us that r equals the square root of 20. And if I simplify that, this simplifies to 2 square root 5. If I simplify the square root. So my radius is 2 times the square root of 5, or the square root of 20. Now to find my center, to find the center of the circle, for the x-coordinate, I'm going to take the number that's here, and I'm going to change the sign. So my center is 3. For the y-coordinate, I'm going to take the number that's here, and I'm going to change the sign. And that's all I have to do. I take the number, whatever number is with the x, change the sign, and that's the x-coordinate of the center. Whatever number is with the y, change the sign, and that's the y-coordinate of the center. Questions on that? Let's look at one where we go the opposite direction, where we know, where we're given the center and the radius, and we want to find the equation. That's just as easy as doing this. So let's look at that example. Everyone good with this so far?
Yes.
Okay. So we have a circle with a center of 4, -5. And radius 7. We want to write the equation. So for our equation, we know it's going to be x and something squared and y something squared equals r squared. So all we have to do to write our equation, I'm going to write x. I'm going to take this number, this first number, change the sign, -4, and square that. Plus, I'm going to write y. Whatever this number is, change the sign, +5, square that, equals, and that equals r squared. So what's the square of 7? 49. And that's all we have to do. Yes. So we just, to find our equation, we write x, take the first number, change the sign, put it right there, square it, write y, whatever the number is, the second number is here, change the sign, square that, and that equals the radius squared. So that's all there is to finding the equation from the center and the radius. Questions on that example? All right, I want to look at one more example just to make sure that, that this is making sense. Let's say we have x plus 3 squared plus y squared equals 15. This is our circle, and we want the center and the radius. So to find our center, I'm going to take whatever number is here by the x, change the sign, and write it down here. That's my first, that's the x-coordinate of the center. I'm going to take the number that's with the y. What number is with y here?
1.
Is it y plus 1 squared, y minus 1 squared? What's adding or subtracting from y here? 0, nothing. There's no number adding or subtracting y here. So this second number is just 0. And so that's the center. And the radius, this is r squared. This number is r squared. R squared equals 15. So r equals the square root of 15. So the important thing to remember here, if there's no number with the x or the y, we're wondering what, we want to figure out what we're adding or subtracting to the x or the y. If there's no number here, then our coordinate of our center is just 0. Yeah, Lynn.
With the first example, you simplified the square root of 20 to 2.
Right.
What is that?
What is what?
Like, what? How did you get 2 times square root of 5?
20 is, did I do that wrong? 20 is 4 times, let me go back, 20 is 4 times, so this is the square root of 4 times 5. Square root of 4 is 2, so I take that out, so that's 2 square root 5. Does that help? Okay. So when there's no number with the x or the y, then our coordinate of that coordinate of our center is 0. We're not adding or subtracting anything, so that's a 0. Let's look at one more example going the other way. Let's say our center is 0, -7, and our radius equals 5, and we want the equation. So we're looking for the equation of this circle. So to write my equation, I'm going to write x, and I'm going to write minus, change the sign on this number. This number is just 0, so x minus 0 is just x. And I'm going to square that, plus y, and I'm going to change the sign on this number, plus 7, square that, and that equals the radius squared. So 5 squared is 25. So the equation of this circle would be x squared plus y plus 7 squared equals 25. Questions on that? So circles, finding the equation, finding the center and radius of circles, really easy. Should be really easy. All right, the last thing we need to talk about today is finding intercepts. So some of your homework problems will ask you to find the intercepts. So finding intercepts is easy. What we mean by an intercept, an x-intercept, is where y equals 0. To find the x-intercept, if we want to find the x-intercept, we plug in y equals 0, solve for x. And the x-intercept tells us where the graph crosses the x-axis. That's what the x-intercept is telling us. It's where the graph is crossing or intercepting the x-axis. So to find the x-intercept, we plug in y equals 0 and solve for x. The y-intercept is where x equals 0. To find the y-intercept, plug in x equals 0, solve for y. And what this tells us is where the graph crosses the y-axis. So to find our intercepts, all we're doing is either plugging in y equals 0 or plugging in x equals 0 and solving for the other variable. Now our circle has two variables, x and y, so we can find the x and y intercepts of our equation. So let's look at a couple of examples of finding intercepts. We want to, was everybody good with that page? Everybody's good? All right. Our example, we have x squared plus y squared equals 47. I'm sorry, 49. X squared plus y squared equals 49. We want to find the intercepts. So if your problem asks you to find the intercepts. To find the x-intercept, we're going to plug in y equals 0. And we're going to solve for x. So when I plug in y equals 0, I get x squared equals 49. To get rid of this square, what do? Square root. So x equals, and when I take a square root of a number, I always get a plus and a minus. So x squared equals plus or minus 14. I'm sorry, x equals plus or minus the square root of 49. So x equals plus or minus 7. So the x-intercepts are plus or minus 7. And this, so when y equals 0, x equals plus or minus 7. So my points here are 7, 0, and negative 7, 0. We said y is 0, so I get a 7, 0 and a negative 7, 0. For the y-intercept, plug in x equals 0. And I'm going to solve for y. So when I plug in x equals 0, I get y squared equals 49. Or y equals plus or minus the square root of 49 when I take the square root. So y equals plus or minus 7. And my points are 0, 7, and 0, negative 7. Those are my intercepts. Questions on that? All right, let's look at one more example that's a little more complicated. We want to find the intercepts of x plus 1 squared plus y minus 1 squared equals 17. I'm going to say 16 just to make it easier. 16. So the x-intercept, I'm going to do shorthand. X-intercept is where y equals 0. So I'm going to plug in y equals 0. So I get x plus 1 squared plus 0 minus 1 squared equals 16. So x plus 1 squared, negative 1 squared is 1. And that equals 16. Subtract 1. X plus 1 squared equals 15. And I undo this square by taking the square root. So x plus 1 equals plus or minus the square root of 15. And to get x by itself, I subtract 1. So x equals negative 1 plus or minus the square root of 15. Those would be my x-intercept. I'd get two numbers there. To find the y-intercept, I plug in x equals 0. I'm going to plug that into my equation. So I get 0 plus 1 squared plus y minus 1 squared equals 16. 0 plus 1 is just 1, and 1 squared is 1. So I get 1 plus y minus 1 squared equals 16. Subtract 1. I get y minus 1 equals 15. This should be squared. Take the square root, so I get y minus 1 equals plus or minus the square root of 15. Add 1 to both sides, and y equals 1 plus or minus the square root of 15. So I get my two numbers for my y-intercept there. So my intercepts, I'm just plugging in x equals 0 and y equals 0, solving for the other variable. Any questions on that? We'll talk a little bit more about circles on Monday. So our homework. Page 614. 11 through, or 12 through 34 even. S 16, 17, I can't remember which one today. The other classes haven't gotten their quizzes back yet, so I'll talk about quiz corrections on Monday. Okay. All right, so there's your homework.